Okay, this is a summarized lecture for chapters 8 and 9. Hope everyone has made out well since Hurricane Irma and are ready to get back to work here. Bear with me as we play some catch up. I think I've got a little bit of a game plan together to highlight some important parts, and then we'll move forward from there. So this is going to be one lecture that covers chapters 8 and 9 on prop performance. And we're just going to go over a few equations. Horsepower is going to be equal to thrust times the velocity in knots divided by 325. Should have seen this equation before. Power required is going to be equal to drag times the velocity in knots divided by 325. And then if you look at figure 8.1, A, it will show thrust required and power required curves for prop-driven aircraft. So go ahead and browse those and take a look at them. Pretty self-explanatory there, but a little bit different since you're using a propeller-driven aircraft. Same with this equation. You've seen thrust required before. It's mass flow times velocity at the exit, velocity at the inlet. Propulsion proficiency is 2 times the velocity at the inlet divided by both velocity exit and inlet. And this is also written for props as THP divided by SHP, where T stands for thrust horsepower and S stands for shaft horsepower. Since you have a prop-driven aircraft, you're going to have a shaft. Read page 111. There's some definitions there that describe the different types of horsepower for a propeller-driven aircraft. Rate of climb is going to be equal to 33,000 times power acquired minus power available minus power required divided by weight. So that's how you'd find the rate of climb for a prop-driven aircraft. Same thing with here. If you wanted to compensate for density, exit over inlet is going to be equal to 1 divided the square root of the density ratio. And there's a couple more ways of expressing V2 divided by V1 equal to 1 over the square root of the density ratio. So here are the most important definitions and equations for chapters 8 and 9 when dealing with propeller aircraft performance. Thank you for your time.